Welcome. This podcast is going to look at hardness and how we can quantitatively measure and calculate the hardness of a material. Hardness is a measurement of the material's resistance to deformation by surface indentation or abrasion. So, the Mohs hardness scale is a hardness test that can be used to look at the abrasion aspect, whether or not something scratches. And if we look at the Mohs hardness scale, we can see that things with a hardness of 1, like talc, would be scratched with something like your fingernail, whereas something like diamond is the hardest object and wouldn't be able to be scratched with anything that is below it on the scale. Another hardness test that can be performed is the Rockwell hardness spherical indent test. And this is actually the test that we're going to be using in our material science class for the lab that we're about to do. So the Rockwell hardness test takes a sphere and applies a known force to the surface of the material by dropping a sphere of known mass from a set height, and then measures the indent. The smaller the indent, the larger the hardness value. So things that are extremely hard will not indent or deform at all. And the softer the material is, the bigger the indent will be. So an example or an application of hardness in real life is, how do you pick your shingles? Do you look for just the lowest price point for hardness? For both? If you live in Colorado, you know that we are frequently victims of hailstorms. And so the class of shingle, class 1 versus class 4, determines the impact resistance for that roof covering. So for example, a class 1 shingle, you can drop a 1.25-inch diameter steel sphere from a height of 12 feet and it doesn't impact the shingle. Whereas a class 4 shingle, you can have a 2-inch diameter sphere dropped from 20 feet without damaging the shingle. So the standard test uses a steel ball dropped from 20 feet to see if the material will crack. And that is because if the material cracks and ruptures, your roof's going to leak. So on a class 4 rated shingle, there'll be no evidence of cracking or tearing present. All right, we're going to use the Rockwell spherical indent test to do a practice problem and a full calculation. As we do this, we'll use the guess method, identifying our given, our unknown, what equation we need, substituting and solving, and hardness is going to be a 4-step calculation process. So we're going to have to go through a series of 4 calculations to get to our final answer. Take a second and pause me and take a minute to record the data table to get us started. So on the data table, one of the first things I can see is that I'm going to be measuring in grams, but I'm going to need to convert that to kilograms to use that measurement. Same with, I'm going to measure height in centimeters, but I need to convert to meters. So to do a basic conversion, I just need to know the conversion equality. There's 1,000 grams in 1 kilogram. Since I'm starting in grams, I would set up a train track and 1,000 grams would be on the bottom, 1 kilogram on the top. So I'm going to divide by 1,000, which means I'm moving the decimal 3 places to the left. In other words, I would have 0.250 kilograms. Same thing as I go from centimeters to meters, I'm going to divide by 100. So 45.8 centimeters divided by 100 would give me 0.458 meters. Once I have all of my units and all of my measurements in kilograms, meters, and seconds, I can solve these problems because I'm going to be calculating energy, and energy units, a joule, is kilogram per meter squared per second squared. So I need to make sure that I get all my units to kilograms, meters, and seconds before I start to substitute into equations. All right, the last thing we need to do to get our data ready to use in our equations is find our average. We won't use the data from any one trial, we'll use the average to do that. So to average, we're going to simply add our values together and then divide by the number of trials or samples we have, in this case 3. So to do that, we'll take 4.85 plus 5.01 plus 4.79, that gets us 14.65. Divide that by 3, the number of trials, and we got 4.88. That number should make sense because that's a number that is larger than the smallest number, but under the largest number. It fits right in the range. All right, here is our 4-step process. We're going to need to calculate the potential energy our sphere has before it indents the surface, the velocity or speed that it's traveling as it indents, the kinetic energy it has, and then finally we can use that to calculate the hardness, because the hardness of an object is its kinetic energy times its diameter of the indenter divided by the potential energy times the diameter of the indent. So it's going to be a 4-step process. Potential energy equation is step 1, velocity is step 2, kinetic energy is step 3, and finally your hardness calculation will be the grand finale. So for the potential energy equation, we're going to take mass times gravity times height. Please note our mass needs to be in kilograms. Acceleration due to gravity is constant since we're on Earth, so you're always going to substitute in 9.81 meters per second squared. And our height should be in meters so that all the units cancel out correctly. So to solve this, I'm going to start by identifying my givens. I know that my mass in kilograms is 0.250 kilograms. Gravity is always 9.81 meters per second squared. And my height is 0.458 meters that I dropped my sphere from. Once I've identified my givens, I can substitute into the equation. So I should be multiplying 0.250 kilograms times 9.81 meters per second squared times 0.458 meters. And when I solve, I should get an answer of 1.12. And let's take a second to look at what happened with units. Because I threw joules on as my unit. Joules is the nice, easy way to represent energy as a unit. But that's because 1 joule is equal to a kilogram per meter times meter, meter squared, per second squared. So again, a joule is equal to or equivalent to kilograms, meters squared, per second squared. And since kilograms, meters times meters over second squared, nothing cancels out, I could keep that as a unit, but it'd be easier to just write it as a joule. Now we need to do our second calculation, our velocity. So the velocity is the square root of 2 times acceleration due to gravity times our height in meters. So to do this equation, I'm going to first start by identifying my givens. Gravity is always 9.81 meters per second squared. Height is the same as what we used in the last equation, 0.458 meters. So since I've identified my givens, I can now plug them into the equation. I'm going to take the square root of 2 times 9.81 meters per second squared times 0.458. So on your calculator, we need to type in second and your square root button. And then you should see a parentheses automatically populate because we need to do everything inside the square root first. So inside the parentheses, you're going to type 2 times 9.81 times 0.458, and then close the parentheses and hit equal to get your velocity measurement, which should be 3.00 meters per second. Note the reason why the unit is meters per second is we have meters times meters over seconds squared, but we're square rooting it. So one of our meters will cancel out and one of our seconds will cancel out. Thus, our final unit will be meters per second. All right, we're halfway there. Our next calculation is to find the kinetic energy. The kinetic energy is the energy that the sphere had as it hits our material surface. So to do that, we're going to take 1/2 times the mass times the velocity squared. Now notice The biggest mistake made on calculators is we're squaring only the velocity value. So that should be your first step in order of operations. Square your velocity, then multiply by mass, then divide by 2. Again, let's look at our data table and previous calculations to get our numbers that we substitute in. Mass is going to be the mass of the indenter that's falling onto our material, 0.250 kilograms. And our velocity came from our last calculation. That's the 3.00 meters per second. So I need to substitute into my equation. I'm going to take 2.50 kilograms times 3 squared divided by 2. So start on your calculator by squaring your velocity. 3 squared is 9 times 0.250 divided by 2. And we should get an answer of 1.13 joules. Note, I can call it a joule because kilograms, meters times meters over seconds times seconds is equivalent to 1 joule. We need to take a second and look at this. It is not an accident that our kinetic energy is very similar to the value for our potential energy, just a slight difference due to rounding. And that is because potential energy turns into kinetic energy. The law of conservation of energy says energy cannot be created or destroyed. It simply changes form. So potential energy is the energy of stored position. As we release that indenter and it starts moving through the air, potential energy is becoming kinetic energy. This is a really important checkpoint in your calculations. You want to make sure that your kinetic energy calculation matches your potential energy calculation. If it doesn't, it tells you either made a mistake in this calculation, likely from not squaring just your velocity value, or in the previous velocity calculation. And the mistake that I see commonly is that students forget to square root that. So now we're to our final calculation, finding the hardness of the material. To do this calculation, we're going to take our kinetic energy and multiply by the diameter of the marble, big D, and then divide by the potential energy multiplied by the diameter of the indent, little d. Note, order of operations matters very much here. We need to divide by both values in the denominator. So I would encourage you to put a parentheses around these two values in the denominator so that your calculator groups and divides by both of them. Or you can multiply by the two values, hit divide by this value, hit equals, divide by the next value, hit equals. All right, let's identify our givens. So we know that our kinetic energy was the 1.13 joules. Our diameter of the marble, we measured marble diameters 14.85 millimeters. Our potential energy was the 1.12 joules. And our diameter of the indent is the average that we calculated earlier for all 3 trials, 4.88 millimeters. So as we substitute into our equation, we're going to take 1.13 times 14.85 divided by parentheses 1.12 times 4.88. Take a second and look at units. How will units cancel out? Hopefully you told me that joules will cancel since we're both multiplying and dividing by it, as will millimeters. And so hardness is one of the few things in science that doesn't have a unit on the answer. So when you solve on your calculator, you should get a hardness value of 3.07. All right, there's some individual practice problems posted on Schoology. I would strongly encourage you to do those 2 practice problems using the guess method. Make sure you're identifying your givens, your unknown, your equation, substituting both the number and units in so that you can check to make sure units cancel properly, and then solving the problem. Make sure to include units. They are super important in the scientific process. One of the key mistakes we see is people not converting to the right units before substituting in. Remember, it's a 4-step process. Start by calculating your potential energy, then your velocity, then your kinetic energy, and finally your hardness. Hope you have a great day. Thanks.